Respected Chair, learned personalities on the dais, off the dais, ladies and gentlemen. Topic of my presentation is zero liquid discharge, current practices. As CEO sir was unable to attend the meeting, I was rushed up for the meeting with small preparation. So I'll take a small, quick view of this company. It's a 27-year-old company where it started with different directions of consultancy, O&M, analytic laboratory development, manufacturing of different work, and energy-oriented works also with audits and water balance study mapping. Our company has a very good production factories on focusing on sewage treatment, WTP and ATP, and we have done wide projects implementation in the long travel. And this company has accredited very prestigious credentials also, and traveled in the last 27 years across over 200 crores as a turnover as of date, with 3,000 employees working on this. And these are some facilities we have, and we have a production facility pan-India for O&M, and we operate on BOO basis also. And we have more clients on experience in the large and small scale implementations. If this is the topic I want to address here, which is more focused on the zero liquid discharge methodologies, in converting or starting from the ETP or WTP, the proper primary treatment, secondary and tertiary treatments are mandatory, where the highest concentration and highest troubles are focused on the zero liquid discharge sections. And how it could be addressed properly with the best available technologies has to be harnessed, and it should be implemented in a proper way, because the emissions are very critical. Even for the domestic groundwater also, there is an intake of plastics into the environment, side. And we have to address all the points starting from the water sources till the implementation of the ecosystems also. So focusing on the current practices of the ME and ATFT or salt recovery portions of the zero liquid discharge, the most cumbersome process, the cumbersome issues comes on the treatment with a high intense energy in other parts, where zero liquid discharge has some claims of references where it recycles the treatment process, which plant discharges no liquid effluent into the surface water, completely eliminating the environmental pollution to the water bodies. On from PCB side of draft, it has been mentioned is the installation of facilities and system which enables industrial effluent for absolute recycling of permeate and converting solid into residue and it's in the form of solid form, and adopting methods for the concentrations and thermal evaporations. On the other side, can be even effective use of the wastewater treatment, recycling and reuse, thereby contributing water conservation through reduced intake of the freshwater systems. So main focus is of the intake. We should be water positive on the directions where industries are pumping water from the ground source or the water bodies in a huge size and quantum. So how it could be made as a better system addressed for the society also should be taken into account, where freshwater intake can be restricted to an extent, adopting a proper recycling methodology. So for any system of zero liquid treatment or any pre-treatment, there are recovery of water and also recovery of salts back into the process, into the factory. And the chemicals or the salts which is taken back to the factory, apart from that, there is a resource of salt recovery apart from that, and also a disposal methodology, because if you are going for any treatment of the final zero liquid discharge, the salt which is generated is a mixed salt. To treat it or segregate it or to dispose it is a huge threat as of date, and there are separate R&Ds taken into account with institutions and sectors where it is addressed properly, but it needs more attention here after also. So if you see more on that, there are many type of applications of the ME and or the evaporation technology, or maybe to the drying sections. In between, there is a section of what the salt recovery also, crystallization and other separation, centrifuge separations are there. But still, there are many technologies which have been addressed, and it has its own proper pros and cons, and it has been having sections on the implementation to have a proper recycling of the water back to the factory. So attempting this side, the high amount of energy consumption like steam or maybe the power was the intense high value which has added to the high capex and opex of the equipment, because in each sections of primary there is a proper pre-treatment. For example, in a primary section, or maybe it will clarify, there's a proper treatment. for a RO system, there's a proper ultrafiltration and proper treatments. But for the ME and ATFT section, there is not a appropriate treatments taken into account, like the reduction of the hardness or reduction of the silica, or very important key parameters are there where it should be reduced, hardness, including the suspended solids. So if it is not done, there is a huge MOC cost, or maybe the designed actions are to be addressed correctly, where it has an impact on the conversion of the process executions. For that, the observations are, it's a high energy intensive actions, high steam consumption, the complexity of operation is very intense, because concentrating the high COD, high TDS, high TSS, high silicate, high hardness, or any other numbers which is in the enriched form as a solute or a brine, it needs a proper operational implementation. Otherwise, the CAP cycle, or maybe the cleaning cycle, the hydrojet usage, it's very tricky part for the operations of the equipment. Otherwise, the efficiency will go down. To meet the discharge limits, or maybe the conditions, will be also a threat for the options. And inefficient stripping in sectors like red categories are also an alarming way, where which it is missed there. It comes to this section where zero liquid discharge operations are suffering a lot. So the recovery of the solvent, ammonia, or whatever high impact toxic things are there, it should be properly recovered, recycled back, or it should be addressed properly before taking into the zero liquid discharge atoms. So if it does a improper actions on this, there will be an inefficient process of operation, where it ends up in a high OPEX, and also the MOC makes into high CAPEX. How to make is a better way to address on this is ends on the hands of the supplier, I mean the technologist and supplier, also on the customers who are adopting that, and also the monitoring sources sections or agencies that is doing through. So focused, take away what it should be taken from here. It is the existing ETP or whatever treatments are there, it should be having a proper tailor-made implementation. If it is having a same methodology of the start from the filtration or settling tank till the ATFT, this might not be a proper answer for the sector wise. We have categorized the sector into different colors, but not the treatments. The treatment should be properly addressed in a right shape for the respective sectors, because some sectors needs proper attention, some sector needs a minimum treatment, and a high recovery of cycling can be done back. So addressing that with a proper engineering, re-engineering on the ETP section might bring up a good value for the actions. It should be taken into account. And as I mentioned, it should be on the proper suitable pre-treatments on the zero liquid discharge atoms, where the primary treatments or the pre-treatments should be addressed correctly for the hassle-free operation of the zero liquid discharge systems. If it is implemented on ETP or WTP, it is more focused for any industry, any scale industries to be adopting more on the sewage treatment back into the cycle also, because the water mapping and water balance should be to a good system. It is addressing not only on the ETP, it's also on the domestic recycling back to the system. So these two are the sectors where energy efficient auditings or water study mapping could be done to make the water positive sections not only on the sector of large scale but also small scale also, because many small scale sectors STPs are not in practice. So take a stand there where it should be uniform for all scale industry and taken actions for that through in the action. And apart from that, any operation of the STP or ATP, if it is through the renewable source of power, it may be a carbon neutral section, it can be an energy efficient way of environmental benefited way of executing the process. So this could be also an attempt which can be taken into considerations of the options. And if you are taking a process of the ETP or any sections for some critical sectors like MSW treatment plants, like leachate treatment plants, there the proper pre-treatment should be addressed, but the RO systems operation on the high COD and high silicon, high hardness will be very tough. There it should be properly addressed accordingly, treated, recycled correctly back to the water bodies with a very good discharge limits, and also the treatment of the sludge or the concentrate again into some energy like biomethanation or some other methodologies of composting should be also addressed on the sections of part. So main focus of this zero liquid discharge attempts can be more focused on the steam saving technologies like adopting vacuum based evaporation technology where the heating source will minimize, or maybe the cooling tower utilization can be eliminated totally if possible. And also there are new inventions and focus coming on the thrust areas of the evaporators and zero liquid discharge attempts, where more research are to be addressed and it should be implemented in the right way to make the action. So altogether, whatever work we are going to do, it is for the environment and for the safety of the mankind. Let us stand together for the betterment of the actions. Thank you one and all. Jai Hind.
Thanks, Vinoth, for completing in time. We can have one or two quick questions if anybody has. Okay. So we don't have time, the organizers are saying. So, and it's a time that all the stakeholders, industrialists, regulators, the government bodies, policy holders, makers, they should come and share the common platform. And I think this IPCC is providing one such platform. So we should come forward, come together on the same platform, share the common concerns, so that the environment in which we are staying, it has to be sustained for a very long time. Thank you very much.